Okay, this question is about to determine the angular position of the sun from the horizontal surface, which is the solar altitude at London on 31st of December at Sol London. Okay, so maybe you can get the equation for altitude angle first, and then see what information you actually need to get the answer. Okay, this is a general equation for alpha. Okay, so in other words, if you want to find alpha, you need to find R, latitude, delta, declination angle, and H, our angle. Maybe you get one by one. For R, latitude, normally given. Okay, so this is coordinate. The first one is latitude, the second one is a longitude. So the L should be 51.5074. Okay, this one is L. Okay, and then delta. Delta refers to the location of the sun relatively to the equator. Okay, so it means that we need to know the date. Okay, and then find where is the location. Okay, so let's find the delta. Okay, so the N is referred to the number of days. So January 1st February, sorry, 1st January is 1 and 31st of December is 365. Okay, so N is 365. So I should be able to get the delta if I substitute 365 into the equation. Can you give me your answer if you get it? Negative 23.086. Okay. Okay, one you guess delta. I think the next one is H. H refers to the hour angle. So anyone have the answer for H? Yes, 0. Because of the solar noon. Okay, when you see that the question state at solar noon, the H will be 0. Okay, so I think we have all the information needed. We can start to get alpha. Share your answer if you get it, because I cannot see your progress. I don't know if you have done the calculation or not. 15.4026. How about the rest? Yes, okay, same answer. Okay, so what can you notice from this altitude angle? Zhongyi, I think it should be 15.4, 0.2657 is too less. Okay, because this you can see that this solar nun. Solar nun means that the alpha is highest or the biggest value. Okay, so in Malaysia, you should see at solar nun, the alpha will be near to 90, maybe 80 something or at least 70 something. But this at London, because of the location, is very north from the equator, so that even at solar noon, the alpha is very less. That's why it means that they will not receive much sunlight even at solar noon. Okay, but this is maybe at the winter, 31st of December. Okay, that's why they are only 15.4026. Okay, normally when you see that alpha is lesser, okay, it also means that the air mass coefficient is higher. Air mass coefficient is the angle sunlight come from the how long is the sunlight pass through the atmosphere, filtered by the atmosphere. Okay, normally low alpha on the particular solution. Although we cannot say that alpha 15, low alpha is directly proportional to the solar irradiance, not that case, but most of the case, alpha low, solar irradiance also low. Okay, but we still have to consider other factors such as the distance of the sun from the earth. Okay, that was not counted in the alpha. Okay. Okay, let's continue with number 2. I think first one we done already. Calculate the position of the sun for Tokyo at 5 p.m. local time on 15th of May. The local time, okay, you cancel the zone. The local time is UTC plus 9 hours. Okay, if you notice, you have UTC and GMT. Okay, UTC refer to the time standard. Okay, so GMT refer to time zone, but actually it will give you the same answer. What I mean is if you write in the sentence, if you talk about the time zone, then you should use GMT. If you talk about the local time, then you should use UTC. Okay, but I don't think it will affect the result. Just definition. Okay, so now you need to find the angle, our angle. So when you ask to find our angle, normally we are not using the which equation contain this hour angle, but we should find the time, the solar time. As long as you can get the solar time, you should be able to get the hour angle, because remember that hour angle is measured from solar noon. At solar noon, hour angle equal to 0, and then 1 hour is equivalent to 15 degrees. Okay, in the afternoon is positive, in the morning is negative. How far from solar? Okay, so I think we need to find the local solar time, LST. Okay, so LST equal to LT plus DC over 60. DC is the time correction factor, and before you get the time correction factor, you need to calculate the equation of time. Okay, maybe you can start with number of n, which is needed in equation of time. the year doesn't matter. We will always assume that every year is the same, although it will slightly different, but we will just assume it's the same. You can see that, okay, just give you some tips. You can see that when we calculate for the location of the sun, we always use the 1 year equivalent to 365 days. And this is used for the every year we use the same thing. Okay, so in other words, the graph that we get actually will be less accurate year by year. You can see that 1 year we skip 0.25 day, quarter of day. Okay, in 4 years time we actually skip 1 day already. Okay, so in other words, maybe 10 years later, when you refer to the internet, you found that the equation will be slightly different already. What I mean is, maybe I show you the actual. But don't worry about this lah. It won't happen now. I mean that in the future, because we keep adjusting the. Anyways, okay. Okay, we talk about declination angle first. Okay, so declination angle here, you can see that we assume that 1 day have 365 days. Okay, and then we have to make the offset, we put 284 plus n over 365 times 260. Okay, but the problem is 1 year we have 365.25 days. So actually in 1 year we skip 0.25 days. In 4 years we skip actually 1 day. Okay, 40 years we skip 10 days. So maybe 40 years later, you may see that the equation here is no longer 284. It may have maybe 294, because we have to start to offset the graph to make it accurate with the correct date. Okay, you get what I mean? Because 1 day we skip 0.25 days. So end of it, for the long term, the effect is quite huge. But for this few years, I think nothing changed. Okay, but for the exam, definitely we can use the same thing. I don't expect you to calculate what happened to the next 20 years or 30 years. But we just consider now. But that's why if you compare your answer here with Google, you may find that it is slightly different. It won't be exactly the same, because Google is a real-time data, which it will adjust the equation every second or every minute. Okay, so their result is always accurate. But this is we fix the equation, or else very difficult. Okay. The rest I think okay lah, because we adjust the alpha only. The rest is quite constant, the equation. And equation of time is also the same thing. Whichever we use an n, like minus 981, this is the offset we make. And again, we consider 1 year is 365 days. So in other words, the equation of time will get not accurate after 20 years or 30 years. Not say not accurate, but we have to offset a bit. Okay, it won't n minus 81 anymore. Maybe n minus maybe it's 91 or what. Okay, this is just for your understanding lah, but we not really need to consider that in the exam. Okay, let's come back to this. So we have to find the equation of time. Okay, so what's the number of n for this question? 15th of May. 135. Okay, one you have the n, then you can get the b. 53.26. 53.26 is a bit slightly out. If your answer 53.26 is actually refer to EOD. Okay, why I say so? If you refer to the graph of EOD, the maximum value is around 16 and minimum value around negative 15. So if your value is out from this range, so normally, G done everything already. Okay, good. The final answer is 53.26. Okay. Hi. Oh, 53.26 is B. Okay, okay. Okay, thank you, G. The rest check the answer. If you can see, you can get the same answer. So EOT 3.7562. Okay, once you have EOT, then you can convert for DC, which refer to time correction factor 4 times longitude minus LSTM plus EOT. Okay, longitude again, we can get from the equation. Longitude is 139.6917. East, so we have put positive. If west, we put negative. Minus LSTM, we convert the time zone into the angle. So time zone is plus 9. So the angle is 15. EOT 3.7562. So time correction factor is 82.523 minutes. How about the rest? Get the same answer? Okay, I didn't get the DC. I get only 22. Yes, correct. Yashing, I get same as you, 22.532. GE, maybe you check your answer. TC. So local time is 5 p.m. Okay, so let's say convert to 24-hour unit. Up to you, right? You want to convert, don't convert. Okay. Oh, GA, no problem. Plus 8. Use plus 8 already because Malaysia time zone. Okay, once you get the RST, then you should able to calculate the hour angle. Hour angle is mean that how many hours from the solar moon. Okay, so now the time is 17 22 31. And then you want to calculate how many hours from sun, you need to minus with the 12. Okay, and then you want to convert to angle, you multiply with 15 degrees. Okay, okay, no issue. Question number 2. Then we move to next question. Question number 3. Calculate the position of the sun azimuth angle for Sydney at 3 p.m. local time on 1st February 2019. The coordinate of Sydney are the and then local time is UTC plus 10 hours. Okay, I think let's start together. Azimuth angle. So to get the azimuth angle, what equation you can use? I think very direct forward lah. You use the equation for azimuth angle. So again, we need declination angle, we need hour angle, and we need alpha. Okay, let's slightly edit the question. 3 p.m. local time, can we change to 3 p.m. solar time? Okay, so that we don't need to do the time conversion. I think you are quite familiar with the time conversion already. We don't need to repeat the practice again. Okay, we simplify it to local solar time. But in the exam, you don't simply go and edit the question. You must follow exactly the question. Okay, then we need to get declination angle, alpha and hour angle. So maybe we can start with declination angle. Direct forward, 3.45 sine. First February, so we know that n is 32. Okay. Excuse me. Any answer for declination angle? Negative 17.5165. Okay, then after declination angle, we need hour angle and alpha. Maybe you try from hour angle. Hour angle again, we calculate from the solar time. Just take note, it's not local time, it must be solar time. You only can direct conversion. If it is given local time, then you have to do the conversion from local time to local solar time first before you convert to hour angle. Okay, H is 3 p.m. So I put 15 minus 12 because compared with the solar moon. So I get 45 degrees. So the last one should be alpha. Then you get the equation for alpha. Okay. Okay, this one you have to be very careful on the direction. You can see that latitude for Sydney is south. Okay, no longer north. Okay, so if you see south, so it means that you have to use a negative angle. Negative 33.8688. Okay, if you get the answer, maybe you can share with us. $49 point. Actually, I get 46 only. 46. How about the rest? 46. Yeah. Okay. Yeah. Good. 46.6882. Okay. So after you get alpha, then we get jack edging angle. Declination angle. $79.4357. Okay. Okay, so now you get alpha. Okay, alpha you get 46.6882. I think everyone can understand what is the angle mean. Okay, so let's say this is the ground and you are standing on the ground. Okay, so this is sunlight. The angle made between the sunlight and the ground, we call it alpha. But now that 79.4357, they were a bit, we need to imagine a bit. Because we know that 79.4357 is mean that the angle of the sun measured from the north-south axis, or polar axis. But from this side, actually, we need to check. Okay, maybe I draw it here. North, south, east, west. And actually, where is the location of the sun? In the first quadrant, second quadrant, third quadrant, or fourth quadrant? You get 79.4357. So where is the location of the sun actually? Any answer? The sun is actually in 1, 2, 3, 4. Now this is Sydney. Sydney is at the middle. So you want to find their location. Okay. So where should be the location of the sun? Two or three. Okay. Yes, makes sense. Because 1 and 4 is actually in the morning. This one have the negative value. This one have positive value. Okay, so whenever it at negative side, so it's just before, so on. So seems like we get a positive value, so either 2 or 3. Okay, So 1 and 3 out, 1 and 4 out. So 2 or 3, then we have to check location of Sydney relatively to the location of the sun. Okay, then we have to draw the Earth. Okay, and this is the north. Middle line is the equator, not the east, it's the equator. Okay, so location of Sydney. Location of Sydney is 33.8688 from the to the south. Okay, and then declination angle is negative 17.51, negative 17 and 33.8. So if I want to draw the location of Sydney on the map, sorry, on the Earth, it should be 33, maybe here. Okay, so this is Sydney. And the angle is 33.8. Okay, according to the latitude. Now, location of the sun, I think negative 17. Location of the sun is negative 17.5. So it's mean that it's 17 degree to the south of the equator. So I would expect it to be here. Okay, so this is a declination angle. So location of the sun here, Sydney is over here. Now we are standing at Sydney. This is the north of Sydney. This is the south of Sydney. Okay, so in other words, if you are standing at Sydney, the sun will pass through the north of Sydney. If you refer to this, because Sydney at the bottom and the sun is on top. Okay, so the Sydney, the sun will pass through the north of Sydney. You will move like this, going up to the other side. So the sun should be over here. Okay, and make the angle 79.4 degree to the north. Okay, this is very important because yes, you may get jack equal to 79 degree, but how you want to apply the 79 degree? Which direction you want to set your panel to face? So like this, definitely I want to put my panel like this. So it's perpendicular to the sunlight. Okay, try to imagine that if you don't know whether 2 or 3, you put the panel like this. You face to this direction because you expect that maybe it's in quadrant 3. Then actually it's out of story lah, because you get nothing. Okay, so the second quadrant. Okay, any question for number 3? You must able to justify location of the azimuth angle. But of course, in the real situation, where it's mean like when the engineer show you your data, they will just give you the value. They won't tell you it's measured from where. So you have to pandai-pandai lah, know what's the meaning of 79.4357 from here. Okay. Same thing in the exam, if they ask for azimuth angle, then you just give your angle. Unless they ask for direction, then you only have to tell where is the exact location. Maybe they ask you to plot it on the direction, then you only plot, or else no need to state it. Okay, if no question, then we move to the next question. Question number 4. Okay, you can start first to calculate the sunrise and sunset time, and also the daylight. Okay, so you need to calculate the sunrise, sunset time, and the day length of Moscow on 30th of June 2018 time zone GMT +4. Okay, again, we define only the local solar time. Okay, we don't need to convert to local time. Okay, so first, what is the condition that you know in this sunrise? Anyone? Alpha equal to 0. Yes, alpha will be equal to 0 at sunrise and sunset. Okay, so from here, you can use the equation for alpha to find the value. Okay, so sine alpha. So to get the time, supposedly you need to get the value of h. This is the final answer that you find. You need to find h. So now left only the declination angle. So this is the, maybe we get the number of n. What's the number of n for this question? One eight one. How about declination angle? Twenty-three point 1845. Okay, so from here, you should be able to get the h. So sine 0 equal to 0. 128.98. Okay, so H is 128.98 during the sunrise or sunset. Okay, of course, I know that positive value refer to the sunrise, sorry, refer to sunset. And you should have another one, negative value, but exactly the same value, which refer to the sunrise. Okay, so now you need to calculate the sunrise and sunset time. Okay, so LST sunrise. So again, I draw the line. This is H equal to 0, solar moon. And here is a sunrise. H equal to negative 128.98. And here is a sunset. 128.98. Okay, so LST in sunrise, we should take the solar noon 12 p.m. Okay, 12 p.m. Then you need to minus the angle over here in degree. Okay, so 12 minus 128.98. Sorry, yeah, one negative only. 128.98 divided by 50. I divide by 50 because I want to convert it back to the hour. Yeah, local time, local solar time, sunset, 12 plus Okay, so the sunrise time is 3 to 4 a.m. and sunset time is 8:36 p.m. Okay, get the same answer. And then the day length. Day length refer to the length of duration from sunrise to sunset. So you can use the time 8:36 p.m. minus 3 to 4 a.m. You should get the time. or you can just directly use angle over here, hour angle. So 2 times hour angle, 128.98 divided by 15 degree. Then you will get the duration for the daylight, which is 17.2 hour. Okay, any question? I think we still have 2 more questions to go. We'll discuss this next week, next time. Okay, no issue, everyone can follow. Okay, if there's no question on the tutorial, then I think we can dismiss lah. Okay, so yeah, sorry, anyone?
Yes, sir, I'm Chie here. I want to ask because I try to calculate the locker time for these question 4, and then the TC that I calculated is quite big, so I don't know whether is something wrong with my answer. Can I check with sir if I did something wrong?
Okay, G, maybe like this. We do it together during
Okay,
the
okay.
next tutorial.
All right, sure.
Yeah, maybe there's a problem, so maybe we discuss together lah. Remind me,
Okay. Yeah.
Remind me, Okay.
Okay,
Remind me
right.
to discuss, Okay.
Yeah,
So as GE requested, so we will continue this question with the local time next tutorial class. Okay.
Okay. All right. Thank you, sir. Thank you, sir.
Yeah. Thank you, everyone. So see you on the next tutorial class. Okay. Bye bye.